Welcome to Bodo's Power Conference 2020. I'm Stephen Oliver from Navitas Semiconductor, the world's first and only GaN power IC company. I'm very happy to be with you virtually for this exciting conference on wide bandgap technologies. Today, we'll learn how GaN-fast power ICs provide reliable, high-performance, fast charging. Navitas means energy, and we bring a new energy to power electronics, the energy to create, the energy to change, the energy to innovate in a sustainable way. Gallium nitride, or GaN, is a new semiconductor material that operates up to 100 times faster than old, slow silicon chips. Early GaN was depletion mode, or D mode, which meant it was normally on, or i.e., a short circuit. This needed complex systems to control power converters. Modern GaN is enhancement, or E mode, i.e. normally off. The key to customer success is Navitas' careful integration of GaN power, drive, control, and protection for high speed, i.e. high switching frequency performance. As you can see, take the best GaN switch, add the best GaN driver, plus control and protection, and you get the world's first GaN-fast power ICs. Navitas uses a proprietary process design kit, or PDK, to create robust, high-frequency ICs. Over 120 patents cover device structures, packaging, applications, and systems. High speed drives high density, and in turn drives lower system costs, as we'll come to later in more detail. Optimized integration means that GaN-fast power ICs are easy to use, high performance, digital in, power out building blocks. Starting with the single GaN-fast power IC, simply use your favorite PWM controller and get high frequency, high density power. As we increase integration, here is a half bridge with 2 GaN FETs, 2 GaN drivers, plus level shifting, ESD protection, and shoot-through protection, etc. You can see a very clean, fast waveform, switching from 0 to 600 volts at 2 megahertz. It's so clean that it looks like a simulation, which makes a power designer very happy. GaN is a high-speed material, but it also requires careful control of the gate. In discrete drive examples, where the GaN FET is a vulnerable 3-terminal switch, complex drive schemes are required for control. Here, we're looking at just one of the downsides to that discrete approach, gate source loop impedance. With discretes, you need a damping resistor to protect the GaN FET gate, but the side effects include power loss and erratic behavior. With monolithic integration of GaN driver and GaN FET, we experience fast, safe, lossless switching. Integration of FET and driver delivers stability, efficiency, and speed. Integration also enables features that deliver simplicity and high reliability. The gate is fully protected. The PWM input is standard 5-volt or 12-volt logic, which means simple layout. Hysteretic input handles voltage noise spikes. So let's see the proof, and we'll first look at power component reliability. Quality is both a core strength and value, with Navitas pioneering understanding in GaN device and high-frequency system-level reliability. Here we see the focus on lifelike operation conditions to push GaN at realistic speed, temperature, and voltage, with solid results proving long lifetime. Navitas has shared this innovative approach with the wide bandgap industry as a founding member of the JEDEC Committee on GaN. Any reliability tests must be supported by ongoing monitoring programs. Navitas is proud to work with world-class manufacturing partners TSMC and Amkor for high volume production and excellent reliability. Since we qualified our GaNFast Power ICs in Q1 2018, production has ramped quickly, with 5 million pieces shipped by July 2020. The production ramp has continued strongly, and we can now update that over 9 million GaNFast Power ICs have been shipped. Reliability testing is at over 3.4 billion equivalent device hours, with over 17 billion field hours, and the fit rate is less than 0.27, and there have been 0 field failures. Let's turn to the market and begin with mobile fast chargers. As you can see on the left, with data from Apple, Xiaomi, Oppo, and all the top phone companies, screen size has increased 3x in the last 10 years, and batteries have grown aggressively too, with the Realme C15 model shipping with a 6,000 milliamp hour battery. If we were to stay with the same 5-watt sugar cube charger from 2010, we would be waiting for over 8 hours for our 2020 phone to charge. As a result, we need more power. On the right, we see the latest flagship releases from our phone company friends, now reaching 50, 65, 90, or over 100 watts. As consumers also want a small size, you can see how GaN dominates the fast charger market, delivering small size and fast charging at retail prices 50% lower than previous best-in-class silicon chargers. Let's look at some of the commercial releases that have driven GaN's adoption in this market. In Q1 this year, Xiaomi, the world's #3 smartphone company, announced its Mi 10 and Mi 10 Pro with a new 65-watt single-output GaNFast charger. A great moment to show how GaN was trusted by a major innovative company. This design used GaNFast Power ICs in an active clamp flyback at 500 kHz, about 10 times faster than traditional silicon chargers, which enabled the use of low-profile, easy-to-use planar magnetics. Let's take a moment and return to my comment about pricing. Here we can see the price and performance of GaN-based chargers versus old, slow, silicon-based designs. A simple snapshot shows how the Xiaomi 65-watt is only one of many GaNFast chargers that offer real savings over previous benchmark silicon chargers, averaging half the size, weight, and cost. Continuing the single output trend, Oppo is another leading smartphone company in the same group as OnePlus and the Realme brands. In July, it announced the 50-watt mini cookie charger, which is on sale next week from December the 12th. High-speed GaN performance is used in a new pulsed topology to minimize the transformer and eliminate the bulky electrolytic hold-up capacitors. This is a beautiful design from the innovative fast-charging leader and is the same size as the popular Wang Wang cookie. In last year's conference, the Basis 65-watt 2C1A was a breakthrough, with GaNFast Power ICs enabling a 3 times reduction in size, weight, and cost. Today, we see big-name OEM companies like Lenovo with their own multi-output chargers, and a broad range of aftermarket companies adopting GaN. The Charge ASAP has now pushed GaNFast charging to 200 watts, enough power for 2 laptops and 2 phones to fast charge simultaneously. Moving on to higher powers, 300-watt AC-DC and DC-DC systems are in mass production with GaNFast Power ICs. As we move into 2021, prototype multi-kilowatt systems in the e-mobility and data center markets will be promoted to production designs. In all cases, high speed, high performance, and high reliability are demanded, and those demands are more than satisfied by GaNFast Power ICs. Thank you for watching this update on Navitas GaNFast Power ICs. I look forward to hearing your reactions, comments, and questions. Thank you also to Bodo and the AspenCore team for the opportunity to speak with you today. Let's go GaNFast.